some examples that have to do with rational coefficients, shall we? And for example, let's take a problem such as 1/4 x minus 1/5 x is equal to 9/2. And now here we're dealing with an equation, and notice that this equation involves some numbers which are rational coefficients here. And looking at this equation, what do you think we'd like to do to both sides? And we're looking at the numbers 4 and 5 and 2, and we'd like to, Tim?
Multiply both sides by 20.
Let's multiply both sides of the equation through by 20, and let's see if we can't do this in our head. 20 times 1/4 is what? 5 times x minus 20 times 1/5 is 4x is equal to 20 over 2 is 10 times 9 is 90, and this is really quite simple. 5x minus 4x, of course, then is equal to x, and x then is equal to 90, and that then is the solution set for this given sentence. Let's look at a few other examples. Well, suppose we had a quadratic, such as 6 is equal to x squared plus 5/2 x. And now we would like to solve this equation for x, and here we happen to have this number 2 in the way. So now what can we do to both sides of this equation, Brenda?
Multiply both sides by 2.
Let's multiply both sides by 2. 2 times 6 is 12 is equal to 2x squared plus 5x. Let's subtract 12 from both sides and then turn the whole thing around. We have 2x squared plus 5x minus 12 then is equal to 0. And you look at it and you say that you hope you can factor. Here we have what? 2x times x is a 2x squared. And now let's see, here we have a negative 12. So what numbers do you think we might put in here? And Doug?
It'll be
Let's
2
see. A minus
minus 3 and 2 plus, and x plus 4.
3 and x plus 4, is that right? Will then give us a positive 8x. Minus 3x is a plus 5x, is that right? And a negative 3 times a positive 4 is a negative 12, and I believe that in fact it does factor. Therefore 2x minus 3 is equal to 0, and we can then state that what? X is equal to what? 3/2, or x is equal to negative 4. And if we were then to write this as our solution set, both of these numbers will make this sentence true, and hence that then is our solution set. Well, let's look at another example. Oh, suppose we had a situation such as this: x minus 2 over 3 plus x over 2 plus 1, and let's treat this as an inequality, is greater than or equal to 0. And again, let's see, what number would you like to multiply both sides of this inequality by? And Glenn?
6.
By the number 6. Now notice 6 is positive, so the sense of the inequality stays the same. 6 over 3 is 2, and let's then try to do that in our head. 2 times x minus 2, Glenn, is
2x minus
2x minus 4 plus 6 over 2 is 3 times x is 3x plus, now be careful, 6 times 1 is 6, and we still have this inequality to deal with. And 2x plus 3x is 5x then is greater than or equal to, there's a negative 4 plus 6 is 2, and then let's subtract 2 from both sides, is that right? And we then will have what? Negative 2. Therefore, x is greater than or equal to negative 2/5, and that then would be its solution set. Well, let's look at one last example, and perhaps we can turn to some word problems. Suppose we were given a situation such as the following: x squared plus 8/3 x plus 4/3. And we were asked to factor this such that the coefficient in front of these factors is a rational number, okay? And for example, what I mean by that is if we were to factor out the number 1/3 from this entire expression, this trinomial, what then would we have here? 1/3 times what number is x squared? Brenda?
3x squared.
That then is a 3x squared plus, and now of course 1/3 times what number is 8/3 x? It would be 8x plus 4. Everyone agree with that? All right, now notice we're not factoring this given expression as we have here, but rather we're taking out that common factor of 1/3 first. And now let's look at it and see what we can say. And you hope now that you may factor this. Well, let's try 3x times x is a 3x squared, And now what are factors here? Anyone, Tom? A plus 2 and another plus 2 will then give us 6x plus 2x is 8x, and 2 times 2 is 4. And sure enough, I think you would agree that we have factored this, in which we have here this rational coefficient. All right? Let's look at a few word problems. Here we have a situation in which it says a basin can be filled by the hot water faucet in 4 minutes and by the cold water faucet in 3 minutes. It can be emptied through the drain in 2 minutes. Presumably it's full at that point. If the drain is accidentally left open while both faucets are turned on, how long does it take to fill the basin? Well, how long does it take to fill a basin? Let's let that be some number, what? X, all right? So let's let X equal the number of minutes, all right, to fill the basin. And let's see what we may say about that. Now, let's come back to the original conditions of the problem. If the hot water faucet can fill the basin in 4 minutes, in 1 minute, how much of the basin is full? And 1/4. So in X minutes, how much of the basin is full? By what? X fourths. Let's write that as 1/4 of X, all right, is the contribution, so to speak, of the hot water. And then at the same time, the cold water faucet is on. So how much of the basin is full in 1 minute if only the cold water were on? 1/3 X. In X minutes, it would be, what, 1/3 of X. And now both of these faucets are on. So if we add these, then this is the total contribution of the two faucets. The trouble is that the drain is open and the water is going out at the same time, all right? And in 2 minutes, it's completely empty. So in 1 minute, how much of the basin is empty? 1/2. And in X minutes, what, 1/2 X. So now what are we going to do with that number? Subtract 1/2 X, and now this then should be equal to 1. Okay, now here again we have a problem, notice, in which we have rational coefficients. So what number are we going to multiply both sides of this equation through by? And Bill?
12.
By 12. So 12 over 4 is 3. So we have 3x plus 12 times a third is 4x minus 6x is equal to 12. Now remember to multiply both sides of the equation by that number. And this is really quite straightforward because we have 7x minus 6x is 12. Therefore, x is equal to 12. And let's actually check this. We have here 1/4 of 12 plus 1/3 of 12 minus 1/2 of 12 is equal to question mark 1. And I believe you'll agree that this is true. We have here what? 3 plus 4 minus 6 is equal to 1, and that certainly checks. Therefore, what was the question? How many minutes does it take to fill the basin? And what? It takes, what is our conclusion? It takes 12 minutes with these given conditions that we have in the problem. Okay? Let's look at another example. One vegetable oil contains 6% polyunsaturated fats, and a second contains 20% polyunsaturated fats. How many ounces of the second oil must be added to 12 ounces of the first if the mixture is to contain at most a 16% polyunsaturated fat solution? Well, we don't have to know too much about polyunsaturated fats, but let's just look at the problem. Now, the question asks how many ounces of the second oil? And the second oil contains what percentage? 20. So let's let what? Let's let X be the number of ounces of the what? Of the second, or let's call that the what? The 20% solution of polyunsaturated fat, okay? Now, let's then come back to the original conditions of the problem. The first one contains 6% polyunsaturated fat, and we started with what? 12 ounces of that. Is that right? So let's talk about pure polyunsaturated fat oil, all right? And what then may we say about that? We have 6% of 12 ounces, is that right? And we may then write that as what? Let's convert to a decimal equivalent, which is what? 0.06 times what number? Times 12. And to that, then we're going to add a pure solution of what? 20%, which is written as what? 0.20 of what number? Of X. All right, and now this mixture, this pure substance now, plus this pure oil, must then be equal to what? 0.16 of what number? Of x plus 12, is that right? Well, let's think of it in terms of 12, which is what we started with. Is that right? 12 ounces of the original oil, and to it we added how many other ounces? Plus x ounces. And let's see now what this number is going to give us. And notice here we have these decimals with respect to so many hundredths, so immediately what do you think might be the best thing to do? Let's multiply by 100. Let's keep these numbers as they are. 6 times 12 plus 20x is equal to 16 times 12 plus x. Now, let's continue this, in which we have here, using our distributive property, 16 times 12 plus 16 times x. Is that right? Now here we have a 20x and a 16x, so what can we subtract from both sides? 16x, and when we do so we have left what? 4x is equal to. Let's subtract this number from both sides, and we'll have what? Minus what? 6 times 12. And on the right-hand side, let's use our distributive property, and what's left? 16 minus 6. And now 4x is 12 times 16 minus 6. What can we do to both sides? Divide by 4. X then is equal to 3 times, and 16 minus 6, of course, is 10. Therefore, x is equal to 30. By the way, we started out here with a sentence in which it says it's to contain at most a 16% solution. So we treated this only as an equation. So I think we had better come back to the original sentence here and now think of this in terms of at most. And therefore, Peter,
It's less than.
you want to say less than or equal to. Does everyone agree with that? In which this then is going to be less than or equal to this, and I believe all the way through here. Now, the only place where we have to be careful is to go from this step, right? From this step to this step, in which we have done what? We have divided by 4, but the fact that the number is positive will still enable us to write this as what? As less than, and here then we have is less than or equal to 30. Okay? Well, I'd rather not check this one, but let's look at another example and see what it looks like. Here we have a discount store owner pays $28 for a transistor radio on which he wishes to make a 30% profit based on a selling price after he has allowed a discount of 20% to his customer. Wow. What price should he set as the list price of the radio? All right? Now, let's take it one step at a time. He buys this radio for $28. All right? He then wants to determine what price to place on that radio, such that if he takes 20% off of that price, that's what he tells his customer. I'll give you 20% off. Now, as soon as he takes that 20% off, he wants to make sure that he's still making 30% on that radio. Okay? So, let's see how it may go. Now, what do we know about cost price and profit and selling price? Is there some relationship that we know about that? And what do we know? Cost price plus what? Plus profit, is that right? The cost price plus profit, you know, is equal to what? The selling price. All right, let's just indicate this in this fashion so that we have some idea of what's what. Now, how much did he pay for this radio to begin with? He paid $28, all right? Now, the question is, what price should he set as the list price of the radio? So what price should that be? Let's let that be, what? Some number, call it X. All right, let's let X be the number of dollars of, let's call that the list price, all right? The list price, which in our case here is really the initial selling price that is listed on the article, okay? Well, the cost price was what number? He paid how much money for it? That was $28 plus now his profit. His true profit is then going to be in terms of his, let's think in terms of his true selling price and see how it will work. Well, let's see now. If it sells for X number of dollars, okay, and then it's a 20% discount, how then may we think of that number? 0.80x. Rather than thinking of it initially as 0.80x, let's call it what? Let's think of it as X minus something, which is what? If it then is what? X minus his discount, which is what number? 0.2, let's write that as 0.20x. Is that right? This then is what he actually sells it for. Is that right? His initial list price less the 20% discount. Now, of this number, what does he want to do but to make what? A 30% profit. So 30% of this number plus his original cost price should be the amount of money that he actually took in. So what amount of money did he actually take in? But what? The same number of x minus what? The initial selling price less that 20% discount. So it's x minus, right? 0.20x. Is that right? Everyone agree with that? In other words, this number then is 0.80x. Is that right? That's the actual amount of money that he took in. Will everyone accept this equation? All right? Let's now perhaps simplify it a little bit. We have 28 plus 0.30 of, and now let's write this x minus 0.20x as, Malcolm, as 0.80x. Is that right? Is equal to, now on the right-hand side, we still have 0.80x. Well, let's work with this and see what we have. Here is 28 plus 0.30 times a 0.80 is what? A 0.24x is equal to a 0.80x. Is that right? Now, if we were to subtract 0.24x from 0.80x, we get what? This then is equal to a 0.56x must be 28. And now, let's then turn the whole thing around. If we're to multiply both sides through by 100, is that right? We'll have 28 times 100 is 2,800 divided by what number? By 56. And what then is 2,800 over 56? Well, what's 28 over 50? 28 over 56 is 1/2. And this is 28 times 100, isn't it? And 28 over 56, which is 1/2 times 100, is equal to what? X then is equal to 50. Perhaps we had better check this problem. Let's see now. We started out with a cost price of $28. To that, we want to take what? 30% of some number. Now, the original list price was $50. Is that right? He now offers 20% off, so 20% of 50 is how much? $10. And so therefore he's going to sell it for what price? 40. And now we want to take 30% of 40 is his profit. Is that right? And the question is this then going to be equal to what amount of money? Of his selling price, his true selling price, which is what number? 40. All right? And let's see if this indeed checks. 28 plus. Now here 0.30 times 40 is what number? Well, 0.3 times 4 is 12. Is that right? And 28 plus 12 is 40, so indeed it checks, and therefore what? The list price should be what? Should be $50. Well, I think that this variety of word problems in which we have some of these rational numbers for coefficients, I hope is helpful for you. So why don't I give you your homework assignment, and you can do some of these on your own.